So I will turn it over to Carlos Valquez to tell us about gem5-dbc.
Thank you very much. So good morning. My name is Carlos Valquez. I'm a PhD student at Jülich Supercomputing Center for Washington Jülich under the advice of Declarative. Thank you very much to the organizers for the invitation to present our work here. I would like you to introduce you today to the gem5-dbc Declarative Benchmark Configuration Framework. This is a framework for Gem5 designed to streamline architecture exploration with Gem5 and to simplify full system simulation workflow. And so the idea is that for a given benchmark definition, given by the initial configuration of your system, a Python model which describes the exploration space and workload to execute, which I will describe later how that looks, and an index of binary artifacts needed to execute your workload. The framework will automatically generate a corresponding set of configuration files, workload, and full system simulation launch scripts, taking a little bit the complexity of doing all of this yourself. And after successful execution, simulation results can be parsed in the JSON or CSV format for use with data analysis tools. And so this framework was developed at Jülich while working on hardware software co-design with Gem5, and has been made public for some months now. What is that? There. And so the goal of this framework is to streamline architecture exploration with Gem5 and to simplify full system simulation workflow. So let me give me some context for why something like this will be needed. As you all know, Gem5 is a very powerful, very flexible computer architecture simulator, originally designed for computer architecture research, with many features and many models available to choose from. But that power and flexibility comes at a cost that there are many moving parts that you need to take care of before you have a working simulation configuration that you can do your research on. Especially if you want to keep everything reproducible. And especially in our case, for architecture exploration, we found that, in our work, we want to benchmark many different applications, a wide range of hardware configurations, a wide range of architectural parameters. And we found that maintaining the procedural configuration scripts was becoming increasingly time-consuming and error-prone. And so this kind of grew out of the need for kind of decoupling the procedural configuration from the architecture configuration, the procedural script from the architecture configuration, and to manage this complexity. And so, of course, these kind of issues are not new, have already been identified by the Gem5 community. Here are 3 examples I take, which are related to our work, but this by no means exhaustive. So, for example, Bruce and collaborators introduced the Gem5 framework to kind of manage the complexity of trying to have reproducible full system simulations. There's also this multi-sim model introduced in Gem5 24.0 to kind of give you a way to manage multiple simulations. And also the original CHI implementation for Gem5 had this kind of had a way to configure the image topology using a separate YAML configuration file. So also this idea of this was an early implementation of this idea of having configuration files read by your Gem5 script and let you change your system configuration by just modifying the configuration file. So this is how the workflow looks like. So this kind of what the gem5-dbc framework implements. And as you see, you start with 3 important input files. So you have your benchmark Python model, which, as we will say later, specifies the parameter space and how the configuration will change on this parameter space. You have initial configuration file, which describes your base architecture, and you have an index of all the binary artifacts you need for full system simulation. And so using this input, the framework generates for you this all the files needed to launch full system simulation with Gem5, and it generates a configuration for each point in your parameter space. And also, you may want to change the workload of the command executing for system simulation, so it generates also that for you. And so once you run your launch scripts, you get some simulation statistics, which you can then parse to JSON. Then you can kind of merge them together on a single data CSV file. And so what specifically this looks like is it gives you a gem5-dbc command line interface, which you can use to generate your launch scripts. And so the inputs, as I said, is a Python model containing abstract benchmark implementation, which I will show you later what it looks like, which specifies the set of parameters to vary, how the initial configuration is to be updated for each set of parameters, the command to execute, the initial system configuration in YAML, and the artifact index listing of the binary files you need. And so we use this word declarative. This is what we mean by it. So you can have either procedural or declarative configuration, each with its own trade-off. So this is not claim what one is better than the other. Each serves its own purpose. And so procedural, you have this kind of what in Gem5 is the default. You construct the system, be explicitly define commands to reach a desired configuration. And a declarative configuration will look something like you describe this final state and let the tool construct the system for you. And so this is the approach we take here, because as our focus is on architecture exploration, and so we work with already established Gem5 models, so we're not trying to test a new model. So we don't need the kind of flexibility that the procedural approach gives you. We prefer to reduce that complexity, and we just need to tell the simulator to set the parameters you want, and please construct a default system using these parameters. And so this is how the initial system configuration and artifact index looks like. So the initial system configuration is a YAML file with support for include directives to enable modular composition, and the artifact index is just a list of binary files you need with some checksums and some metadata that the framework uses to, for example, give the right root file system partition in 5. And this is the other main component, the benchmark specification. So this is how you tell Gem5-dbc what you want to do. So you have this section get var params, where you return after a list of parameters and parameter values, which will produce your configuration, your parameter space. There is an option to filter parameters when for some reason they're not valid, and then the update config will just update this config object, which is used to construct your system based on the set of parameters. And this generates individual configuration for each point in the parameter space. Then you have this get command and get env methods, which will tell the Gem5-dbc framework how to generate the workload to run on full system simulation, and then get data losses, a way to extract the information from the generated statistics and generate your data CSV file. So by implementing this abstract benchmark, specifying what you want to do, and by giving the initial system configuration and the list of binary files needed, then gem5-dbc can take this and generate for you our set of scripts need to just run the full system simulations. And so at the end, when your simulations are finished, you can parse them to JSON and evaluate all JSON files to a single CSV file. And so, of course, by doing it in this way, you give up some flexibility for ease of use. And so, because, of course, the framework cannot generate all possible configurations for you, currently, we support atomic simple and out-of-order CPU models only for ARM. The cache hierarchy is standard parallel L1 and L2 with hardware prefetchers and shared 3. If you want to research some other cache hierarchy, then of course you can write it yourself, but it's not out of the box. We support Classic and Ruby, CHI only, interconnection model simple and Garnet, arbitrary 2D mesh, and simple memory and DRAM memory controllers. And this is kind of the default network topology you can configure. So this is kind of out of the box. But if you want to do other system configurations, you can do them, but then you will need to add the filter by yourself. But gem5-dbc, of course, will support that with the same workflow. I don't know how much time I have. So yeah, so as an example exploration, if you want to have a very simple experiment, you want to take a look at the sustained memory bandwidth on SC-vectorized string triad benchmark, and you want to see what the impact will be changing, for example, the SVG length or the existence or the existence of the hardware prefetcher. And you could take this some initial system configuration and define that you want to try these parameter variations, and you will do it like this. You will do define a balance class with your parameters and implement get var params so as to return the parameters values you want to look at. Interval params will be true because this is a simple parameter range, so there are no conflicts between the parameters, and then get the important method review of the config. So we have this config object, which is very close in while after the gem5 models itself, and you can use it to change based on the params, generated params. So the system will give you the Cartesian product of these parameters and feed them to update config, and then you can create for all the parameter variations and individual configuration. And for example, in here you select the number of CPUs, the SVG length, and then set the prefetchers to either none or leave them alone based on the input parameters. You define the environment and the command you want to execute on the full system simulation. You can use this kind of YAML syntax to, for example, declare the number topology. And yet then you use the gem5-dbc will create the launch scripts for you, and you can run your simulations without having to modify or create a Python configuration file yourself. So in summary, the gem5-dbc framework streamlines architectural exploration across a large number of system configurations by introducing a declarative configuration model that simplifies for system simulation workflows. For a given benchmark definition, the framework automatically generates sets of configuration files, workload for system simulation launch scripts for a range of configurations across a defined parameter space. And the main design goal of gem5-dbc is to simplify the configuration management and reproducibility of small and large-scale architectural explorations in 5 for both beginner and experienced users. And this has already been used at the EPI project. The gem5-dbc framework has significantly contributed to architectural exploration and co-design within the EPI collaboration and has been successfully used to manage a variety of poly simulation studies.
Great, thanks, Carlos.
Thank you very much.
Question?
Hello, I have maybe a quick, simple question. So if I'm interested in using this to evaluate some custom hardware emulated components, so if I had my own sim objects, for instance, how easy would it be to
Yeah, exactly. So it should be easy to do. You have to do it yourself, but the framework is designed in such a way that you can just add your custom sim object to the configuration object, and then it will give you you can use it to configure your own.
Okay. And how easy do you expect would it be to port your efforts to RISC-V? Because as I read, it's only supported for ARM right now.
Yes, so exactly, we're looking at that because we also have some colleagues interested in that. We're planning to do that. I cannot give you a time frame, but yes, we are also interested in having support for RISC-V.
Okay, great. Thank you.
Thank you.
Any other questions? I have one quick question. Can you talk about the differences between your declarative framework for the workloads and what the gem5 resources provides? Because it looks similar to me.
Yes, so yes, so the idea is that you have this benchmark definition and configuration file and artifacts to keep track of your binaries, and it will generate all these launch scripts for you to start your simulation.
Maybe let's take it offline, but it looks like there's some other out there. We should talk about how we
Yes, definitely. Yes.
better work together.
Yeah.
Any other questions? Okay. Thanks, Carlos.
Thank you.